Hi everyone, welcome to my YouTube channel Blue Bio Learn. Here, we explore interesting topics in life sciences. In today's session, we're going to cover structure of atoms, molecules and chemical bonds, a complete concept explanation followed by important MCQs for CSIR NET Life Sciences. Let's get started. Coming to the structure of an atom's key points definition, types and atomic mass. Structure of an atom. An atom is the smallest unit of matter that still has the properties of an element. It has a dense central part called the nucleus, and around it, a cloud of tiny, negatively charged electrons. The atom is made up of three main particles. First one is protons. This is positively charged, found inside the nucleus, with a mass of about 1 atomic mass unit. Second one is neutrons. This is neutral in charge, also in the nucleus, and nearly the same mass as protons. Third one is electrons. This is negatively charged particles that move around the nucleus in different energy levels. Their mass is so small that it is almost negligible compared to protons and neutrons. In a neutral atom, the number of protons equals the number of electrons, keeping the charges balanced. Protons and neutrons make up almost all of the atom's mass, while electrons occupy the space around the nucleus. Now, let's talk about atomic mass. It is the total mass of an atom, mainly from the protons and neutrons in the nucleus. The tiny mass of electrons is usually ignored in this calculation. We can estimate atomic mass by adding the number of protons and the number of neutrons. Next one is atomic mass unit. The unit used is the atomic mass unit, where 1 atomic mass unit is 1/12 the mass of a carbon-12 atom. For example, hydrogen has 1 proton, so its atomic mass is about 1 atomic mass unit. Oxygen has 8 protons and 8 neutrons, so its atomic mass is about 16 AMU. On the periodic table, the atomic mass you see is usually a weighted average of all the naturally occurring isotopes of that element. Next one is structure of molecules. A molecule is the smallest unit of a substance that can exist independently and still retain the chemical properties of that substance. It is formed when 2 or more atoms join together through chemical bonds. Same element molecules, for example, O, oxygen, N, nitrogen. Different element molecules, right pointing arrow example, hydrogen oxide, water, carbon dioxide, carbon dioxide. Types of molecules. 1. Diatomic molecules, contain exactly 2 atoms. Same element, N, O. Different elements, Colorado, HCl. 2. Polyatomic molecules contain more than 2 atoms. Examples, carbon dioxide, 3 atoms, carbon tetrahydride, 5 atoms, C. Hydrogen oxide, glucose, large molecule. How molecules form. Atoms combine to become more stable, usually by achieving a full outer electron shell. Sharing electrons, right pointing arrow forms covalent bonds, e.g., H, CH. Transferring electrons, right pointing arrow forms ionic bonds, e.g., sodium chloride. Exists as a crystal lattice, not as separate molecules. Last one is structure of chemical bonds. A chemical bond is a force that holds atoms together in a compound. Bonds form because atoms seek a more stable, lower energy state, often by completing their outer electron shell. Coming to the types of chemical bonds. First one is ionic bonds. Formed when one atom transfers electrons to another, producing oppositely charged ions. Example, sodium donates an electron to chlorine, forming Na&Cl. These ions attract each other strongly. Ionic compounds often form crystals and conduct electricity when melted or dissolved in water. Second type is covalent bonds. Formed when 2 atoms share 1 or more pairs of electrons. Nonpolar covalent, right pointing arrow equals sharing of electrons, e.g., H, O. Polar covalent, right pointing arrow unequal sharing, leading to partial charges, e.g., hydrogen oxide. Covalent bonding gives molecules specific shapes and properties. Third type is metallic bonds. Found in metals, where electrons are not tied to any one atom but move freely in a sea of electrons. This explains why metals are good conductors of heat and electricity and are malleable and ductile. Fourth one is bond characteristics and stability. Bond strength, right pointing arrow stronger when bonds are shorter or multiple, double, triple bonds. Bond length, right pointing arrow the distance between the nuclei of bonded atoms. Bond polarity, right pointing arrow influences interactions such as hydrogen bonding and dipole-dipole forces. In this video, I've briefly explained the structure of atoms, molecules, and chemical bonds. In the next video, I'll post the MCQs. We've covered only 5 MCQs here, More exciting questions are coming in the next video, so stay tuned. Thank you for watching. I hope you found this video helpful. Don't forget to subscribe.